In example 1, we will design a box beam. This beam is made by nailing together 4 boards in the configuration shown in this figure. The simply supported beam supports a concentrated load P at the mid-span. So if the allowable shear stress in the nails is 115 MPa, so what is the minimum diameter of the nails that can be used? The dimensions A, B, T, and delta S and L have been given, right? So here it's a typical design problem. We can just follow the 5 steps to find the answer. Okay, so in the first step, we just find the V, right, the maximum shear force, right, the V max. Okay, we have done the V diagram here, so the maximum V value will be half P. Right, this is 2.5 kilonewton or 2,500 Newton. Okay, step 2, we will find Y bar and I. Okay, so this is a rectangle, so it's easy to find the global centroid right here. So the Y bar equals B over 2. That is 150 millimeter from either top or bottom. It's the same, right? They will be the same. Then the I can be calculated by 2 methods, right? It's a sum of ICI plus AIDI square. In this example, you have 4 sub-areas, then you just add them together. Right? Just calculate 2 values, multiply by 2, you will get the result. Or we introduced a simpler method in the last lecture, right? You can use the big BH cube over 12 minus the BH square over 12 of the smaller rectangle, right? Hence, in this example, you have the bigger one and a smaller one, right? You have 2 sets of BH cube over 12 values. So just use the bigger one minus the smaller one, you can get the I, right? So in this case, the bigger one will be the bigger B value will be A plus 2T, right? This is A plus 2T times B cube over 12 minus the smaller values will be A times B minus 2T cube over 12. Okay, you have these 2 sets of methods, 2 methods to calculate the I. And I'll give you the results directly. It will be 302 million millimeter to the 4th. Step 3, we will calculate the Q. Right, the Q equals AD and the area is right here, and the A is just obviously A times T. Right, this is the A times the D value. Right, this will be so the D will be Y bar minus half T. Right, you get 200 times 25 times Y bar is 150 minus 25 over 2. Okay, you get 687,500. And step 4, we'll calculate the Q. right? The shear flow, the Q equals VQ over I. That is 2,500 times the Q value over the I value, that is 302 million. Okay, you get 5.69 Newton per millimeter. Then the last step, we can design, we can select the minimum diameter of the nails. Right, we have two equations that you can use, and the central equation, the core equation, as we derived previously, the QS smaller than, not higher than M times the V pin. And we know the V pin can be calculated from A pin times allowable shear stress, and the A pin equals pi over 4 D pin square. Right? So we have the three equations. We can get a overall equation to design it. Right? So you have actually here QS not higher than M times pi over 4 D square times allowable shear stress. Okay, so here that you will have 5.69 times 125 smaller than M. What is the M value? Okay, you have 2 rows of nails. Okay, so M is 2. Okay, M is 2 times pi over 4 D pin square times 115. So you can solve this equation. You will find that the D pin should be not smaller than 1.98 millimeter. Okay, so using a diameter larger than 1.98 will make you your beam safe. Okay, it will be a good design.